Hi, welcome. This is Jane. In this session, we're going to solve free response questions and learn to strategize. Grading. FRQs are graded using a scoring guideline that looks like this, and you gain a point for every item you hit on this list. So the scoring guideline is on the FRQ archives page at the College Board's website. So make sure to download it and use it to grade your own work. I'll show you how it's done during this session. However, you can also lose points. Here are the list of things that you should avoid. Let's look at them one by one. First one, array collection access confusion. So array lists and arrays have different ways of fetching items in the list. And for array list, you need to use the array list method get to fetch an item. For arrays, you'll need to insert the index number within the brackets. Next, extraneous code that causes side effects such as printing to output, incorrect precondition check. So there is no need to print anything when you're writing this out on a piece of paper, right? So simply put, don't do anything that is not required. Next, local variables used but not declared. So here's an example. Let's say that integer I and IR are all declared except for a counter that will take off a point. So make sure to always declare your local variable. Next, destruction of persistent data, such as changing value referenced by parameter. So let's see what that means by looking at this example. We have a method called mystery, and it takes a parameter, which is an integer array called old R. And let's say that this mystery method takes old R and it's going to return an array with all the negative values from old R. So we're not allowed to alter old R in any way. So let's make a copy of it. So how do you make a copy? Does this look right? No. So if you actually do this, you are going to end up altering old R. And that is because new R is a reference variable that is going to point at the same array object as old R. So if you alter new R, old R will also change because they're pointing at the same object. So you'll need to copy the array the proper way, and this is how you would do it. So you would declare new R with the same length as the old R, then using a for loop, copy what's inside old R over to new R. So another thing that might help you with the FRQ in dealing with arrays is that when you're asked to create a method that takes an array, you don't always have to copy it to a new array. You can actually copy it to an array list, and that will help you when you are required to remove items or change the length or the size of your list. Next, void method or constructor that returns a value. And this one's easy. So no return statement for void methods, no return statement for constructors. So this is the problem solving process that we're going to go through with the FRQs today. And notice that writing the code itself is step 3. It's not step 1. And that's because understanding the problem is half of the work. And when the question is well defined in your mind, the rest should come easy. In this session, I'll be modeling problem solving in following steps. Number 1, understand the question. So this is where we define the question in our own language and terms. And then number 2, we're going to write out a pseudocode. If the question is too simple, you can skip this step. Number 3, write the code. So this is where you would actually write down your solution on a piece of paper. And 4, if time permits, check your logic and your syntax. And while you're practicing, measure how much time you should spend for each step. And the first question on array list, you'll have 25 minutes. And the second one is for 15 minutes, so plan accordingly. Use the talk aloud technique, also known as the rubber duck debugging, to help you think through. And describing your code out loud and hearing your own logic can be very effective. And one last thing before we actually get into the problems. So minor syntax errors or mistakes are permissible, And I won't get into too much detail here. The information is available from the FRQ scoring guide. Let's begin the FRQ practice, and we're going to be looking at the 2019 exam question 1 and 3. So download it and print it if you can. All right, let's begin. So this question is 2019 FRQ question number 1A, and it's a classic CS 101 type coding assignment where you deal with calendar methods and leap year. So what is a leap year? Well, it's a year that occurs every 4 years that has 366 days instead of 365, and it has February 29th. So we need that extra day added to the calendar to sync with the Earth's orbit around the sun. And the most recent leap year was year 2020. So let's take a minute to look at the class AP calendar and also read what's required for question A. Okay, so let's first look at what's available in the class AP calendar. First, we have private static boolean is leap year method that takes an year and it returns a boolean value, true or false, probably if that given year is a leap year or not. And then it has static int number of leap years, and this is part of question A. So let's look at question A and see what's required. Write the static method number of leap years, which returns the number of leap years between year 1 and year 2 inclusive. In order to calculate this value, a helper method is provided for you. So these helper methods is a must. You have to use this in your method to gain a point. And like we've guessed, it returns true if year is a leap year and false otherwise. So I'm going to use a post-it note to write down my pseudocode. So I'm going to use a post-it note to write down my pseudocode here. And because we're going to have to keep track of number of leap years, I'll need a counter variable. So first I'll need a counter. And then I'm going to loop through each year from year 1 to year 2, inclusive. And for every iteration, I'm going to need to check if that year is a leap year or not. And if that year is a leap year, then we're going to have to update the counter, increment it by 1. And once we're done with the loop, return counter. Okay, so step 3, let's write our code. Open curly brace, and we'll need to instantiate our counter, which will be set to 0. Then we're going to use a for loop to iterate. And we're going to begin our counter from year 1 and loop until I is less or equal to year 2. Increment I by 1. Pseudocode 1, line 2, taken care of. Now we need to use an if condition to find out if our given year is a leap year or not. So once again, we're going to have to use this helper method. So is leap year. And then insert I. If the condition is true, then we're going to update the counter, increment it by 1, close, close, and of course we'll need to return our counter. Semicolon and close. So that completes the method, and we've pretty much covered everything that's on our pseudocode. Next, let's read aloud what that code is. Next, let's review the code by reading it out loud. So, number of leap years method takes year 1 and year 2 and returns how many leap years are in this range. Define the counter variable that will be returned and iterate from year 1 to year 2, and using an if condition, if is leap year returns true, then increment the counter. And finally, return the counter. Okay, let's use the scoring guideline to see how we've done. First one, initializes a numeric variable. Yes. Loops through each necessary year in the range. Yes, year 1, year 2 inclusive. Calls is leap year on some valid year in the range. Yes, I is in that range, and we're calling is leap year. So +1. Updates count based on result of calling is leap year. Yes. Returns count of leap years. +1. So this would be 5 out of 5. Next question, question B. So take a minute to read through the question and see if you can define it in your own terms. So for this question, we're going to have to create a method called day of week, and it's going to take month, day, and year as its parameter, and return which weekday this date falls on. And when creating the method, we're going to use the two helper methods given here, first day of year and day of year. So let's see what that does. So first day of year is going to return an integer representing the day of the week for the first day of year. 0 denotes Sunday, 1 denotes Monday, and 6 denotes Saturday. For example, since 2019 began on Tuesday, since 2019 began on a Tuesday, first day of year returns 2. Okay, so it looks like if we can keep a table of the index number and the matching weekday, that'll be helpful. So 0, 1, 2, 3, 4, 5, 6. 0 represents Sunday, then Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. There's another helper method called day of year, which takes month, day, and year, returns n, where month, day, and year specify nth day of the year. So for example, January 1 will give you 1, and January 10 will give you 10, January 21 will give you 21. So we're going to have to work with the return values of the two methods and create an algorithm that calculates what day the given date is. So let's write this pseudocode by working through this example here. So we'll figure out what day of week returns when we plug in January 10th, year 2019. So it tells you it's going to return 4, but let's see how we can get this number. So when we call first day of year on 2019, it's going to return Tuesday. So Tuesday is 2, and so first day of year 2019 is going to return 2. And we're looking for January 10th, which means that when we call day of year, pass January 10th, 2019, it'll give us 10. So what do we do with these two numbers? If it's hard to imagine, let's draw out the calendar here. So we have 1 on Tuesday, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we drew that calendar to figure out the algorithm, not to get the actual answer. So basically what we're going to do is we're going to get the index number or the weekday number of January 1st and add nth day to the weekday number. But because the nth day includes January 1st, we'll have to minus 1. So basically we'll have to add first day. I'll just put FD for first day. Add day of year, and maybe I'll call that nth day, and do a minus 1. So if the given date is January 21, you'll be adding first day, weekday number 2, plus 21 minus 1. So in this case, our first day, the weekday index is 2, and we're going to add 10 to it, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And because that 10 day, it includes day 1, we're going to have to do a minus 1. And to figure out what day this falls on, we'll have to do a modulus 7 on this whole equation here. So modulus 7 is basically going to remove all the redundant or the repeating parts and just get the remainder. So if this is a little confusing, let's start assigning weekday index to these dates. So the weekday index for January 1st is 2, and then the index for January 2nd is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And that cumulative weekday index for this example is going to be 2 plus 10 minus 1. That is 11. 11 modulus 7 is going to return 4. And that modulus 7, what it actually does, it removes all the repeating weekdays from 0 to 6 and leaves just the remainder. So that modulus 7 is going to wipe out everything from 0 to 6 for the first line and leave you with 6th, 7th, 8th, 9th, and 10th. And 10th falls on weekday index number 4, which is Thursday. So basically this would be our pseudocode, and let's start writing out our solution. So open curly brace. We need to get the information from the two helper methods. So integer, I'll call this a first D, and this will be assigned the value returned from first day of year, and we're going to pass year as the argument. Next helper method we're going to use is the day of year. The variable name is going to be nth D, day of year, and we're going to pass month, day, year as its argument. And the month, day, year, they come from the method parameter. And here's the highlight of the code. All right, we're going to have to return the weekday of this given date. And we're going to add the first day with the nth day minus 1, because January 1st is inclusive. And then we're going to have to do a modulus 7 to get the remainder. And that's our algorithm for getting the weekday. And of course, last one would be return weekday. And close the method. Let's score this. Calls first day of year, +1, yep. And then calls day of year, yes. Made that call. And calculate the value representing day of the week, yep. Well, it doesn't tell you what the correct formula is, but you can actually see that from the solution provided. Then return the calculated value. Okay, so that would give us 4 out of 4. And notice that even if you get this third line, the core algorithm, wrong, you still get 3 out of 4. Next question. Let's go to page 9, question 3. So step 1, read the prompt and scan the code for a minute. For this question, we're going to work with delimiters. A delimiter is a non-empty string that acts as a boundary between different parts of a larger string. So let's look at this example here. We can see that we have parentheses, which are the delimiters, and notice that they match. So we have an opening delimiter and a closing delimiter. The second example here, delimiters don't match, right? We're missing a closing parentheses. And the second example, we have a opening B tag, a closing B tag, and the one below that, the B tags don't match. And here we have a class called delimiters. And this delimiter class has two private instance variables for open del, open delimiter, and close del. And we're going to be setting these instance variables with the constructor delimiters. And these instance variables are going to be set when the constructor is called. And below the constructor, we have a method called getDelimitersList, and this is going to be part of question A. Okay, now let's take a look at question A. So let's try reading the question for a minute and try to define the question in your own terms. So for this question, we're going to create getDelimitersList method that takes tokens array and returns an array list of all the delimiters in that array. So here is my pseudocode. We're going to loop through tokens. If elements match the open del or the closed del, then add it to the array list. And return the array list. Okay, so let's start hand coding. Open curly brace, and we're going to first have to define that array list that we're going to use to add the open delimiter and closed delimiters. So array list, and this is going to be a string array list called dlist new array list of string type. We're going to loop through the tokens array using a for each loop for string t of tokens. Then let's use an if condition to see if t matches any of the open delimiter or the closed delimiter. So t dot, we're comparing strings, we'll have to use dot equals open delimiter. So we're going to see if t matches open delimiter or the closed delimiter, and we're going to use the or operator and put t dot equals closed del. And if t matches any of the open del or closed dels, then we're going to add it to the list. And close if, close for, and last statement will be our return statement. Return dlist. Close the method. So let's review. We're going to create getDelimitersList method, and this method is going to take tokens array and return an array list that contains all the open and closed delimiters, and return that array. Okay, let's try scoring this. Create array list string +1 there accesses all elements in array tokens. Yes, we're doing that using a for each loop. And compares string and tokens with both instance variables. Yes, both. We have them both here. So +1 there. Then adds delimiters into array list in original order. +1 there. Okay, so this we have 4 out of 4. Next question, 3B. So read the instructions for B for a minute and try defining the question. So for this one, we're going to create the isBalanced method, which takes the delimiters array list and returns a Boolean value of whether the delimiters is balanced or not. And here are the two conditions that will return true for is balanced. So condition 1, when traversing the array list from the first element to the last element, there is no point at which there are more closed delimiters than open delimiters at or before that point. So this means that when your closed delimiters exceed the number of open delimiters, this will return false. Number 2, the total number of open delimiters is equal to the total number of closed delimiters. So once we're done with the loop, then we'll have to compare the open D's with closed D's, and if they match, then it's true. If they don't match, then it's false. So here are the examples. The first one has 1, 2, 3 open subs and 1, 2, 3 closed subs, and this also meets condition 1. So example 1 works. Example 2, we have open sub, close sub, close sub. So by the time we hit index 2, we have more close subs than the open subs, and this will return false. Example 3, same. Example 4 does not meet the second condition. It has 2 open subs and 1 close sub. So here's my post-it where I'm going to write down my pseudocode. We'll first need to create counters for the open delimiters and closed delimiters. So counters for open delimiters and closed delimiters. And we're going to loop through the delimiters array list. And while we're doing that, we're going to count open delimiters and also count the closed delimiters. Also, for every iteration, we'll need to check the first condition. And if closed delimiter is greater than the number of open delimiters, then we're going to have to return false. Once we are done with the loop, then we'll have to check the second condition. Okay, so let's start coding. Instantiate our counter variables, integer, and we'll call it open C for count, set it to 0, and also we'll need to count the closed C's, also 0, and we're going to use a for each loop to iterate through the delimiters array list. And we'll need to count how many open delimiters and closed delimiters there are. So if d dot equals open del. Now note that the open del comes from the instance variable. Then update open counter, increment it by 1. And let's see what comes after this. So because the content in the delimiters, it's either going to be open delimiters or closed delimiters, we'll just use an else statement to count the closed dels. Then we'll have to do one more thing while we're iterating. So we've taken care of the counters, and we're going to have to check against the first condition. So we'll use an if statement to do that. A brand new conditional tree. If closed C is greater than open C, then return false. Close. And our loop is done. So check, check, check. And because we don't have enough space, let me move this around a little bit. Now that our loop is done, let's check condition number 2. If open C is equal to close C, then what are we going to return? We're returning true. And else, return false. Close, close, and the method is done. So there are several ways of coming up with a solution for this. Another way of doing this would be to create a Boolean variable called isBalanced and set that to true to start with, and then check against condition 1 and 2 throughout the code, and at the end return isBalanced. So the isBalanced Boolean would work like a switch. All right, let's review. So we're creating an isBalanced method, and that method takes delimiters array list and returns a Boolean value of whether the delimiters are balanced or not. We're instantiating counters for both openDel and closedel, and we're going to loop through delimiters array list and count how many openDels and closedels there are. Then we're going to check against condition number 2 while we're looping. If close C is greater than open C, then we return false and we're done with the method. If we don't meet this if condition, then we finish looping through the delimiters. Then we're going to check condition 1, which compares open C and close C. If they're equal, return true, else return false. All right, let's score this. Initializes accumulators. Yes, we have open C and close C to do that. Accesses all elements in ArrayList delimiters. Yes, we're doing that using a for each loop. And using a for each loop, we're safe in terms of having to deal with bounds errors. Then compares strings and delimiters with instance variables and updates accumulators accordingly. Yes, we're using instance variable openDel, and we're updating our accumulators OpenC and closeC accordingly. +1 there. Then identifies and returns appropriate Boolean value to implement one rule. Yes, one rule. In this case, we're checking against condition number 1, so satisfy that one rule. And the last one, identifies and returns appropriate Boolean value for all cases. Yes, so case number 1, case number 2 are checked. So that gives us another point, and we have 5 out of 5. So that ends our FRQ practice session. Good luck on your exam.